So for problem 22 in chapter 11, I need to find how far a swan has traveled in its metabolic energy and the fraction of its body mass that it loses um, over a 12-hour flight. It gives the mass and the speed of the swan in the problem. And so to find the distance of traveled of the swan, you do x equals velocity times change in time, which will be the 20 meters per second times the 12 hours converted to seconds, and you'll get 864 kilometers. Now, to find its metabolic energy that it used, we first need to find the mechanical energy required for the whole flight. And so to do that, you'll plug in the given 100 watts equals what you would use the P equals E over change in time, and you'd solve for E. And that energy would be 4.32 times 10 to the 6th joules. And once you have the mechanical energy required for the whole flight, you need to solve for the chemical energy. Since the swan is similar to that of a human, you can set it up so 0.25 is equal to that joules we found before over the energy we need to solve just for the swan during this flight, and you get 17.3 times 10 to the 6 joules. Next, to find the fraction of its body mass that it loses, you're going to find from the table that 1 gram of fat is equal to 37 kilojoules to burn. And so you can set up this equation where the mass of fat is equal to its chemical energy over Q. And so you'll plug in your values here and get 467 grams. Now, to find this as a fraction of the mass it loses, we'll set up the mass of that the swan loses over its total mass, and you will get 4.67% of body fat lost.